Kia ora, Year 12. I'm going to look at the second part of this complex numbers question now. This is definitely one of the more challenging questions in today's tests, and I think it's very similar to a scholarship calculus question from a couple of years ago. I haven't had time to look, but I will dig it out over the next couple of days. So there are two ways I think that you can do this question. I'm going to timestamp the video or put a note in saying where I start the second method. But the first way that I'm going to do it is just to start by saying that we know that W is equal to cis 2 theta. Right, so that's equal to cos of 2 theta plus I sine of 2 theta. I'm going to substitute that in here and work through the left-hand side. And I'm going to use my double angles directly in here. I'm not going to multiply by the conjugate over the conjugate. So that's the second way that we can do this question. Right, so the first way is this. On the left-hand side, we've got cis 2 theta minus 1 over cis 2 theta plus 1. So substituting in, we get cos of 2 theta. I'll do the take away 1 now. So cos of 2 theta minus 1 plus I sine of 2 theta divided by cos of 2 theta plus 1 plus I sine of 2 theta. I haven't finished marking yet, but I think most of you probably have gone from here and gone times the conjugate over the conjugate, right? But I'll come back to that method. What I did instead is I just shoved in all my double angles, and then I looked for ways that I could simplify. So really important in this question that you're always looking at where we're trying to get to, which is to I tan theta. So we want a whole lot of stuff to factorize away. And that's why in this first one, I chose to put in 1 minus 2 sine squared of theta, take away 1, plus 2 sine theta cos theta times I. And then in the denominator, I'm going to use the other double angle identity. So 2 cos squared of theta minus 1 plus 1. And then my double angle sine, 2 sine theta cos theta I. And you can see that quite a bit of stuff is going. So we've got negative 2 sine squared theta plus 2 sine theta cos theta I. And down here we've got 2 cos squared theta plus 2 sine theta cos theta I. I'm going to take common factors out, and I'm also going to divide by 2, right? So let's divide every term by 2. Whoosh, they go away. Right, now I've got in the numerator sine of theta into negative sine theta plus cos theta I over cos theta into cos theta plus sine theta I, or plus I sine theta. So this is looking pretty good. This is not looking quite how we want it. So what I'm going to do instead with this is, I don't even really know why I did this, but I just took that negative and thought that I kind of want to switch over my cos and my sine and not have this be a negative. So I'm going to replace that negative with I squared and just see what happens. So we've got sine theta times I squared sine theta plus cos theta I. For some weird reason, the fan on the laptop has just exploded. Hopefully you can still hear okay. Now look what's happened. I've got a common factor now. By replacing the negative 1 with I squared, I can take out a common factor of I. And you can see that we're almost there, right? So look what we've got. We've got I sine theta plus cos theta. So that should make you very, very happy, right? Because that's what we've got down here, cos theta plus I sine theta. So there you go. Now we can simplify here and here, and we've done what we needed to do. So, oops, I don't know what happened there. Let's get rid of that. Let's try that again. So crossing out those, and we've got tan theta times I, which is the right-hand side as required. Right, so that's the first way to do it. Now the other way to do it, going all the way back to the start, and yes, I am going to do it again, because I think some of you will probably watch both ways, is the kind of obvious thing to do that we've learned with complex numbers all along, which is that if we've got a fraction, then we can deal to it by multiplying by the conjugate. So we've got cos of 2 theta plus 1 minus I sine of 2 theta. And we're doing that up here as well. So I think pause the video at this point if you haven't done it this way and just see how far you get with it. What does it do that is different from my way? Well, I think it gets us, yeah, it's you don't have to do the cool thing that I did with seeing that the -1 is the I squared, right? So it's probably a slightly more mucky expansion, but the steps fall out better. Right, so in the denominator, we get pretty cleanly cos of 2 theta plus 1 squared, and then these go with this as usual, and then we have minus I squared, so plus sine squared 2 theta. And you know that some of this is going to go with this, and so on, right? And then in the numerator, we get a difference of 2 squares, so cos 2 theta minus 1 times cos 2 theta plus 1 plus I sine 2 theta into cos 2 theta plus 1. So I've done those ones, and now I'm doing these ones, minus, so now these, let's take out the I. So sine 2 theta cos 2 theta plus 1 minus sine 2 theta times cos 2 theta minus 1. And then lastly, we've got minus I squared, so plus sine squared 2 theta. Right, so kind of a whole lot of stuff to expand, but a pretty easy expansion. So let's do the real bit first in here. We get cos squared 2 theta minus 1 plus sine squared 2 theta. Right, and there's a lot to like about that because that's going to go to 0. Plus I times this sine 2 theta cos 2 theta plus sine 2 theta minus sine 2 theta cos 2 theta plus sine 2 theta. Right, so that's the numerator done. And then down here, we get cos squared 2 theta plus 2 cos 2 theta plus 1 plus sine squared 2 theta. Right, so I told you this way was a bit messier, but it's going to be easy when we get a bit further through. Right, you're not going to get to a line like a few of you did in class and just go, what do I do now? So here we've got 1 take away 1. And in here, this and this go together to give me 0. So it's plus 2I sine 2 theta over 1 plus 1 plus 2 cos 2 theta. Right. Okay, hopefully guys you are doing this with me as I go and you're maybe pausing and doing quite a bit on your own. So here 2 sine 2 theta I over 2 plus 2 cos 2 theta. Right, let's divide through by 2. That gives me numerator, what have we got? 2 sine theta cos theta I over 1 plus cos of 2 theta. So we'll do 1 plus 2 cos squared theta minus 1. That gives me what I want. So 2 sine theta cos theta I over 2 cos squared theta, which is equal to sine theta over cos theta I, which is tan theta times I. So as I said, I really think they misjudged that question for 4 marks, or maybe they were just trying to put it in as the one really challenging question in the paper, because it certainly takes, you know, that's taken me about 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of working, which is quite a bit to do. All right, so thanks for watching, and let me know if you had any other cool ways to do that one, and I'll have a look at them.